Gigabyte built the world's first metal 3D printed $3,000 motherboard for space and for your PC. Well, sort of. This is the new AORUS X870E Infinity Next, and according to Gigabyte, part of this motherboard uses the same 3D metal printing techniques used to manufacture rocket thrusters and satellite components, which sounds completely ridiculous. And that's because it is. After seeing it in person at Computex 2026, I couldn't stop thinking about it. Not because it's practical, not because anybody actually needs one, but because this might be one of the most over-engineered motherboards ever created. The funny thing is, this technology isn't actually even new. If you're a Formula 1 fan, you've probably heard about teams experimenting with incredibly complex 3D printed cooling structures and aerodynamic components that traditional manufacturers simply couldn't produce. In some cases, the designs became so effective that governing bodies stepped in and restricted what the teams were allowed to do with this technology. Another example is Bugatti. They used the metal 3D printing to create titanium brake components and lightweight structural parts for their Bolide hypercar. Not because it was cheaper, but because traditional manufacturing couldn't create the shapes the engineers wanted. The idea was pretty simple. If you can create shapes that weren't possible before, you can solve problems that weren't possible to solve, like cooling a motherboard in space. And that's exactly what's happening here. Gigabyte isn't using 3D printing because it's easy, they're using it because conventional CNC machines physically can't produce structures like this, which is needed to effectively cool motherboards in space. So while I was at Computex, I met up with Gigabyte's product manager, Andrew Yu, to find out why a motherboard suddenly has more in common with a rocket engine than a gaming PC. Here at Computex 2026, we have the Infinity Next, a fully 3D printed motherboard launched for the very first time. And Andrew's going to give us a little bit more insight about it because this thing's next level. If I'm not mistaken, this is the same technology that they used in Formula 1 a while back where they banned it because of some reason. I have a Formula 1 fanatic friend who told me about it a little bit ago. Is that true? Do you know anything about the similarities in the technology?
Hi everyone. So this actually is the first space tech motherboard we tried to do because Gigabyte is too good on doing the motherboard. So we already reached our finished all the ideas. So what's to do next? So next step, we think the concept will be to space. What if a motherboard existing in space that is able to work? So we actually co-work with vendors that actually do the rocket thruster materials and make the SpaceX or some like satellites to make it happen on the injector. So with that same materials, we have the 3D metal printed manufacturing technique into this motherboard. Yeah. So it's really insane because all the board of the heatsink, all the backplate, and all the VRM on top are using the 3D metal printed. Yeah.
Am I correct in saying that this helps with heat as well? So we'll have more performance because we don't have the heat problems of the motherboard itself holding on to all of that energy?
Yes, exactly. So traditional 40 fins already reached its own limit from our point of view. So that's why if the cooling surface area is something is really critical for the space cooling because you don't have the airflow. So the only rely is how much the cooling surface area you can have. So that's why with our co-work with the rocket thruster vendor that we have implemented such kind of a structure called AI Gyroid. So it's something like you have enlarged the thickness, also the hole, some through hole inside the heatsink, and able to provide 44% more compared with the traditional design. Yeah, this is really insane.
I do have another question though, and this is a difficult one.
Yeah.
It's new technology.
Yes.
We don't have mass production for it yet. How much higher of a price can we expect to pay for this?
Well, this is something we are also trying to break the record. No, I'm just kidding. So for sure, as you may know, that 3D metal printing is not something like a mass production wise. It's more focused on the peak performance. So of course, the build cost will be, compared with the traditional design, will be high. So we don't have the final answer yet. We're observing the opportunities and observing the feedbacks from the customers. So we are based on the final products of how the combination goes and the recipe goes and give the final MSRP to the customers. Yeah. Now, if that does sound slightly insane, that's because it is. According to Andrew, Gigabyte partnered with companies that manufacture aerospace components and adapted those same 3D metal printing techniques for the cooling system on the Infinity Next. The heatsinks are 3D printed. The backplate
also 3D printed. Even the internal cooling structures are 3D printed. And unlike most concept hardware, there is actually a reason for all of this. Gigabyte calls the design an AI Gyroid structure. Instead of using traditional cooling fins, the heatsink is built around a complex internal lattice that massively increases surface area while remaining lightweight. According to Gigabyte, that gives them up to 44% more cooling surface area compared to the conventional heatsink designs. And honestly, when you see it in person, it looks less like a motherboard and more like something that belongs inside of a spacecraft. Which is fitting because underneath all of the futuristic metal artwork sits a 64-phase VRM built from 80 amp hour stages. On paper, that gives us a theoretical 5,120 amps of power delivery capacity. And no, your processor doesn't need anything close to that, at least not yet, which is exactly why this motherboard exists. The Infinity Next isn't trying to be sensible for the average consumer. It's Gigabyte asking what happens when traditional, mass-produced motherboard designs stop being the limitation. And that's what I find interesting, because I don't think this motherboard is really the product. I think the manufacturing technology is. And that's why I asked Andrew whether we could actually see this technology make its way into other things like graphics cards and other products, and his answer was,
Well, we are open for any options, so let us know. How do you feel like on this motherboard, and how do you feel like on launching this on other product lines? We're observing like new opportunities, and we're trying to look on infinity and beyond.
And honestly, I hope it does. Not because I think we're all about to buy a $3,000 motherboard. Technically, it's gonna cost more since the manufacturing costs alone were $3,000. But because some of the best innovations in PC hardware starts as a project, exactly like this one. A crazy idea, a ridiculous budget, a group of engineers asking, what if? After spending a week at Computex in Taiwan looking at AI everything, this was one of the few products that genuinely surprised me. It's excessive, it's over-engineered, it's probably going to cost a small fortune, and that's exactly why it was one of the coolest innovations I saw at Computex 2026. What are your thoughts? Is this something really cool to you as well? Did you see anything else at Computex 2026? Let me know in the comments down below. This was Stefan from Computex, reporting on everything cool, spending the money, sometimes wasting it, so you don't have to. See you in the next one. Cheers, bye.